Let's continue with the 30, 60, 90 triangles. So just to review what we just learned, or hopefully learned, at minimum what we just saw, is if we have a 30, 60, 90 triangle, and once again, remember, this only applies to 30, 60, 90 triangles. This angle is 30. This is 60. And if I were to say the hypotenuse is of length h, we learned that the side opposite the 30-degree angle, and this is the shortest side of the triangle, is going to be h over 2, or 1/2 times the hypotenuse. And we also learned that the longer side, or the side opposite the 60-degree side, is equal to the square root of 3 over 2 times h. So let's do a problem where we use this information. Let's say I had this triangle right here. It's a 90-degree triangle. Let's say that this is 30 degrees. And we could also figure out, obviously, if that's 30 and this is 90, that this is also 60 degrees. And let's say that the hypotenuse is 12. The length is 12. And we know this is the hypotenuse because it's opposite the right angle. What is this side right here? Well, is this side opposite the 60-degree angle, or is it opposite the 30-degree angle? It's the 30-degree angle that opens into it, right? I drew this triangle a little bit different on purpose. The 30-degree angle opens up into this side, and it's also the shortest side. And we learned that the side opposite the 30-degree angle is half the hypotenuse. So the hypotenuse is 12. This would be 6. And this side, which is opposite the 60-degree side, is equal to the square root of 3 over 2 times the hypotenuse. So it's the square root of 3 over 2 times 12, or it's just equal to 6 square roots of 3. Another interesting thing is, of course, the longer non-hypotenuse side is square root of 3 times longer than the short side. I don't want to confuse you too much. Let's do another one. Let's say this is 30 degrees. It's our right triangle. And I were to tell you that this side right here is 5. What is the length of this side? Well, first of all, let's figure out what we have. 5 is which side? Oh, if this is 30 degrees, we know that this is going to be 60 degrees. So 5 is opposite the 60-degree side. And x is the hypotenuse, since x is opposite the 90-degree side, and it's also the longest side of the right triangle. So we know from our formula that 5 is equal to the square root of 3 over 2 times the hypotenuse, which in this example is x. And now we just solve for x. We can multiply both sides by the inverse of this coefficient. So if you just multiply 2 times the square root of 3 times the square root of 3, and then 2 times the square root of 3. Oops. You can ignore this. We get 10 over the square root of 3 here. And of course, this 2 cancels out with this 2. This square root of 3 cancels out with this square root of 3 is equal to x. And now, if you watch the last couple of presentations, you realize that this could be the right answer. But we have a square root of 3 in the denominator, which people don't like because it's an irrational number in the denominator, and I guess we could have a debate as to why that might be bad. So let's rationalize this denominator. So if we say x is equal to 10 over the square root of 3. To rationalize this denominator, we can multiply the numerator and the denominator by square root of 3, right? Because as long as we multiply the numerator and the denominator by the same thing, it's like multiplying by 1. So this is equal to 10 square roots of 3 over square root of 3 times square root of 3. Well, that's just 3. So x equals 10 square roots of 3 over 3. This hypotenuse. I know I confused you. And of course, so if this is 10 square root of 3 over 3, right, that's the hypotenuse. We know that the 30-degree side, right, this is 30 degrees. We know the 30-degree side is half of that. So it's 5 square root of 3 over 3. Anyway, I think that might give you a sense of the 30, 60, 90 triangles. I think you might be ready now to try some of the level 2 Pythagorean theorem problems. Have fun.